My name is Malik Salimullah Said, chemical engineer by profession, serving water industry for the last 30 years. Today's our topic, a table of the content, which my presentation will cover is the basic technologies, water chemistry, pretreatment option, desalination technology and filtration process, or reverse osmosis work, factor affecting the performance of RO plant. Unless we have some idea about the first 4 or 5 steps, we cannot gauge the performance of factor affecting the performance of our plant. That's why I have added some parts for better understanding of the listeners and the viewers. Basic terminologies which are used uh, uh, in our plant system. Basically, we have a feed water line. By high pressure pump, we feed the water to the membrane, and we have two outcoming stream. One is permeate, which is of low TDS, and other is of reject, which is of high TDS. Normally, the units which we use is the cubic meter per hours, as the density of water is 1, therefore its mass and the volume is same. 1 liter is equal to 1 kg, and sometimes we call the unit as tons per hour, sometimes liters per hour, gallons per minute, and gallon per day. These are the terms which will be used in our preceding presentation. So first of all, we should understand the recovery of the RO system. That what is recovery? Recovery means product divided by the feed. I giving you the example, permeate flow divided by the feed flow into 100 is the percentage recovery. If we have 100 cubic meter per hour feed and 75 cubic meter per hour is the product, it means that we have a 70% recovery. The recovery depends upon the feed water quality. In a typically low TDS water, we can have a high recovery. Then on the C water category, we have a 30 to 40% recoveries of the system. Now, first of all, we need to understand the path length of the membrane. The recovery is also dependent upon the path length of the membranes. And if one pressure vessel has a 6 modules of the membrane, it means this vessel has the 6 path length. If 2 vessels are installed in the series, or the 3 vessels they are installed in the series, feed water is entering separately to each of the vessel. The path length for each shall remain 6. Now, if we come to the 2-stage systems, on the first stage, we have the 2 pressure vessel, and in each pressure vessel, we have 6 membrane, and the reject of the first 2 enters into the second stage. That means the total path length of this system is 12. Hope you will understand it, because in the first stage, we have the 6 water is flowing from the 6 modules from each pressure vessel, and its eject is passing through the second stage, which also has the 6 membranes per pressure vessel. It means that water is passing through total 16 membranes, 12 membranes, sorry, and its path length will be 12. This is the 2-stage system. Now we have a 3-stage system in which we have stage 1, stage 2, stage 3. And in this case, similarly, the water will be passing through 6 plus in the first stage, 6 in second stage, and 6 in third stage. The path length in this case will be 18. That is very important factor for determining the recovery of the system. From an individual membrane, we can have only recovery up to 10 to 15%. And it is not possible to get the high recoveries with the low path lengths. And with 3 stages, we can have a recovery with low TDS up to 99%, 95% recovery. It all depends upon the feed water quality and especially TDS, which we are feeding. For TDS up to 500, we can go, or one tap water, if we go for the tap water less than 1000, we can go to 85 to 90% recovery. That depends upon various other parameters as well. Okay, the path length, what is the path length and the relation between the path length and the recovery of the system? With the one membrane, which means the path length is 1, we can maximum have a 15% recovery. But with the two membranes, we can have up to 20 to 30% recovery and so on. You see, when we have path length 12, it goes to 75, and between 75 and 80% recovery, and beyond that it's up to the 90%. Now, an important factor other is the what loading rate we are putting on the membranes and how much membranes are required for the system to produce the required quality and quantity of water. Normally, unit of measurement for this are GFD, gallons per square foot per day, or some of the software they use liters per hour per square meter. And these are the two parameters which are recommended while we design the RO system, that the RO permeate its flux range should be, if we are using a double pass RO system, like from one RO plant, we are recycling into the second RO plants, then we can operate on the high flux, and that is 22 to 28 GFD, gallons per square feet per day. That determines the number of membranes for the system. If we have a deep well, water recommended flux of the various membrane manufacturer is 18 to 22. For the shallow wells, it is 16 to 18, and for the surface water, we have to have low flux for on the membrane so that its performance and the life cleaning frequency is in the acceptable range. For the wastewater, usually we keep the wastewater recycling, we keep the flux as low as 18 to 12 on the membranes while designing these systems. Now, another factor, important factor is when we design the RO system, and we need to have a good operation and maintenance of the system to reduce the cleaning frequency and the fouling of the membrane. All the membrane manufacturers, including Dow, Hydronautics, Torre, Coach, and every membrane manufacturer, they recommend the SDI. SDI should be less than 3. If the SDI, silt density index, is more than 3, as it increases, it will increase the falling frequency and increase the cleaning frequency of the pretreatment. Normally, less than 5 SDI is okay, and you can see if the SDI is less than 1, several years without colloidal falling, membranes can survive, and on less than 3 SDI, several months required between the cleaning, two cleanings. And if SDI is 3 to 5, and particular falling likely, a problem frequent cleaning is required, and greater than 5 SDI is normally unacceptable, and we need to improve the pretreatment. That depends what type of particulate matters are present in the feed water, and we have to design the system accordingly to ensure that SDI is below than 5. What is SDI? How we measure it? Basically, this is the formula for determining the SDI. We take the sample in 5 minutes. SDI range is 0 to 20, and 10 minutes 0 to 10, and 50 minute sample 0 to 6.67. The total time, test time, is around 15 minutes for SDI, and we have a kit. I will show you how this kit is designed and how it works. This is the kit for SDI. We feed install a pressure regulator wall, the ball wall, and the pressure gauge. We put the millipore filter holder and paper of 0.04 micron and pass the water through it. The micron size of this filter, millipore filter, which are very popular, and that is 0.45 micron. And we check that how much is the filling time for the 500 ml graduated cylinder. And that determines our SDI, and this kit can in around 30 to 50,000 you can develop, and it will surely help you in determine the SDI of the feed water to enhance the life of the membrane and reduce the clearing frequency of the membranes. Now, this is the recovery. I have already explained you the product divided by feed into 100 is the recovery of the system, and similarly the salt passage and the product water having the salt divided by the feed water having the salt concentration into 100, that is salt passage normally called that. The salt passage of the system comes around to be 1 to 2%, but for the individual membrane, the salt passage is around 99.5 to 99.7%. But when it goes into the system, you have installed 6, 8, or 12 membrane path length, then around 1% you see overall rejection, and that we will discuss in later. What about water chemistry? The feed water, basically it is all the matter of pre-treatment, how we can have an efficient RO plant, reliable RO plant, and how we can improve the efficiency, consistent performance, constant TDS and flow, how we can maintain it. We have to design a very good pre-treatment to meet the feed water condition as proposed by the membrane manufacturer. If you go through the data sheets of the membrane which you are using in the RO plant, or the UF or the NF or the MF membranes, you will see the whole data sheet has given the feed water conditions which must be followed, and they also give the tolerance of the temperature, pH range that should be maintained. Once we maintain those conditions, we can enhance the life of the membrane and the system, and consequently the operating cost will decrease as the cleaning frequency of the system of membrane or the membrane will decreases. And in total solids, when we have raw water, we have two types of contaminations in the raw water. One is the suspended impurities and other are the dissolved impurities. Total suspended solids. Suspended solid, we separate it by means of various application that depends upon what type of a solid we have. It is a dirt, sand, silt, or the microbes. For each, we have a different equipment or technology which we can select for the pre-treatment. We can go for the sand filters if we have the suspended solids around 40 milligrams per liter, and if they are above that, then we will have to go for the clarification, coagulation, flocculation process, followed by the sand or the multimedia filter. And if we have the organics present in the raw water, then we will have to do the chlorination, disinfection, so that we can avoid the biological falling from the membranes. These are various suspensions which we need to remove in the pre-treatment to make water fit for the RO feed. And normally the unit which we use for this concentration of various impurities, these are parts per million ppm or milligrams per liter. As already I have told you that the density of water is 1. That's why volume by volume and mass by volume units are same in case of water. Total dissolved solids. Now, we categorize the total dissolved solids which are present in any source of water. We have the cations. You can see these are the potassium, sodium, magnesium, calcium, strontium, barium. We have the anions, carbonate, bicarbonate, nitrite, nitrates, chloride, fluoride, sulfate, and silica. And these basically cations and anion individual concentration we can check in the raw water, but they exist in different form. Maybe the sodium will be existing in a molecular form with sodium carbonate, or calcium will be in calcium carbonate, calcium bicarbonate, and sodium chloride or sodium fluoride. The combination of these molecules is different, but we are more concerned about the concentration of the ion, and in the lab test report, we normally see what concentration of cations and anions are present in the feed water. And it is very important to, whenever you seek to have a RO system or you implement the project, you must have the complete water analysis so that you can design, or your system supplier have a complete data to design the pre-treatment and the RO plant based on the composition and the contamination of the raw water. Normally, we have observed that people say, okay, give me 10 RO plant of 100,000 gallon, and its TDS are 5,000 or 10,000. It doesn't serve the purpose, but contractors or the EPC companies, they are compelled to do it. Sometimes the company like us, we have a lot of experience, and we know that if the plant is being installed at Sheikhupura, Faisalabad, or site area at Karachi, Korangi, Landi, or any other, we have the reference, a lot of references. We can pick up the closest plants analysis but still it is not the actually the professional approach. That is, they just give us the idea, but it's most important for individuals or the companies who intend to install the RO plants. They must get the water analyzed with respect to its contamination, especially total suspended solid and its nature, and then the total dissolved solids and their nature, what type of a contamination is present, and the other contaminants, which are the organic pesticides, phenolic compounds, color, taste, odor, and heavy metal. We need to have the removal of these all contaminations, other contaminations through the pre-treatment prior to feeding and to the RO plant. There's a pH scale, the pH scale, you all are well aware, it is a concentration of hydrogen ion in the water. And from 8 to 14 is the alkaline range, and 0 to 6, you can say, is the acidic range. pH versus temperature. These are the important factors when you are operating an RO plant. You must know that the temperature, feed water, or the product water temperature, that these have the direct impact on the pH values. As the temperature increases, pH value has a decreasing trend. You can see from this graph, because we have the bicarbonates HCO3, and they dissociate into the carbon dioxide and hydroxyl ion. They increase the alkalinity of the water, and these are the reason. That's why by decomposition of various ions, the aqueous solution, you can see equilibrium shifts, and we have the different pH at different temperatures of the same TDS of water. And this is the relation between TDS and the conductivity. Normally, measuring TDS, it requires some time, maybe a few hours, because by the evaporation method at 450 degrees C, we evaporate in the lab and take the water results. And the instant measurement is through conductivity. Conductivity and the TDS has some relation, and around 50 to 70% of conductivity, they reflects and the TDS. If your TDS are 1000, or your conductivity is 1000, the TDS will be around 5 to 700, and this relations is a linear, and you can see this graph. This is the indicative only if you are operating your own RO system, and you can develop your own factors by analyzing the reading coming on the permeate or the feed water conductivity meter, and you can test the TDS in the lab, and it will give you the exact conversion factor for you. In the world, there is no TDS meter available. All conductance, all the measuring equipment for the TDS, they are based on the conductivity. Only what they do is on the dial they change the TDS relationship, and on the dial indication you receive that ppm. But on the behind the principle is conductivity, conductance, and they correlate the conductivity with TDS, and that is displayed on your analog or digital controllers. There is also relationship between TDS and the temperature or the conductivity and the temperature. You can say most precisely. You can see here, as the temperature increases, the conductivity of the water increases. At 15-degree temperature, you see here you have conductivity. You have a 15-degree. You have this conductivity around 975, and as it goes up, you can see that its conductivity is gradually increasing. This is the linear increase, and these are the some curves established from various quality of water. This is also in relationship with the standard solution, which has been developed to just reflect between the relationship between the conductivity and the TDS. What is the composition of the fresh water, brackish water, and seawater? Fresh water is basically the tap water, which is potable, drinkable, and it's less than 1000 TDS, and its composition in the percentage tentative which we have. I have mentioned in these slides that you can see the most of the ions are 30% sodium and 30% chlorides, and in brackish water 1000 to 10,000 TDS we have around 46 to 45% sodium chloride ions. And in seawater, we have 30%, 55%, and these are the major impurities which we have in the various sources of water. There are no doubt more ions present, like heavy metals and suspended matter as well, iron, barium, aluminum, sometimes fluorides, but this is the data just representing the major constituents which have more than around 1% concentration in various type of waters. Pretreatment option. Pretreatment options basically are to operate it right, design it right, maintain it right. That's the objective that we should focus mainly on the pre-treatment of RO plant if we want to have the long life of the membrane, if we want to reduce the cleaning frequency of the membranes. And pre-treatment, only the pre-treatment can ensure your long life and the reliable operation. What is the optimized flow? You will get product quality, consistent recovery, operating and maintenance cost. It will be optimized, less fouling, less scaling, less membrane degradation due to the minimum cleaning frequency, and appropriate pre-treatment. Our objective always remain that increase the efficiency, increase the membrane life, consistent performance of the plant, reduce the cleaning frequency, and meet membrane feed condition. That's very important. I must once again I emphasize, whichever membrane you are using, just study their data sheet and ensure that you are meeting the feed water condition as per recommendation of the membrane manufacturer. Normally, pre-treatment is ensured to achieve the following condition. I have taken this data from one of the membrane manufacturers data sheet. The brackish water membranes, they have maximum operating temperature 45 degrees C. These are the limiting factor which should be considered in the pre-treatment of RO plant. The maximum operating pressure of the membrane is 41 bar, maximum pressure drop 15, PSI, pH range should be between 2 to 11, pH range short term during cleaning. Sometimes we require the acid cleaning, sometimes we require the alkaline cleaning for various type of fouling. And for that matter, for the shorter duration, as mentioned, for 30 minutes, you can operate on the RO membrane, you can clean by keeping the pH 1 to 13. But for the consistent operation or the continuous operation, you must ensure that the pH is between 2 to 11. But it is the job of your designer who is proposing you the system that whatever pH he recommends as per the composition of your raw water recoveries, and you should be maintaining that condition. And this guideline basically for designers who are who can manage their system according to the limit factor given for the membranes. And then you see the maximal oil SDI is 5. That to me it's a very key important factor in the performance of RO plant, that it's avoid the particulate fouling. And the tolerance for the free chlorine is zero point 0.1 ppm. Basically free chlorine or any oxidizing agent, any KMN, it could be KMNO4, it should be free chlorine or sodium hypochlorite, and or any oxidizing agent. This tolerance limit for that is less than 0.1 ppm. Then we have a limit for the iron, Fe+2. Iron exists in two forms. One is ferrous and other is ferric. And the concentration for both has been mentioned, and it is better to remove the iron if it is present in the source of water. That can be done by installing the brim or filter, or you can oxidize ferrous into ferric by chlorination or by oxygenating the ferrous, and then you can remove it from the sand filter. And the COD limit set for the RO membranes is 10 milligram. It is important here that when we go for the recycling of wastewater treatment plants, this limit cannot be achieved. That COD should be less than 10 milligram. For that matter, the experience of the company or the technology supplier or the recycling system supplier matters a lot. But normally, we have observed that up to 100 milligrams per liter COD recycling plants, especially UF, are operating on that, and the outlet of UF or the we have a COD at the feed of RO plant around less than 50. That's normally being observed, but all depends upon your designer who's designing the system and how well he designed the pre-treatment to achieve these values or come close to these values for the smooth operation of the plant. What are the pre-treatment options? In pre-treatment, sometimes to where we have especially the increased recoveries of the system, we have the acid addiction, and if the organic matters are present, bacteria, algae, we have to do the chlorination. Once we do the chlorination, we have, as defined earlier in the data sheet, then we have to do the dechlorination. It can be done by incorporating an activated carbon system filter in the system, and or by the sodium by the addition of sodium metabisulfite. Antiscalants, scale inhibitors, they are essential for the feed water treatment, and otherwise we will have to lower the pH or place the softening plant in the pre-treatment, but still we will prefer that the good antiscalant should be used for, and there are a variety of antiscalants available for various applications for the silica-based, iron-based, and other compositions which are ions which are present in the pre-treatment. I have been given the slip that I have left with the 10 minutes. My friends, I have to quickly finish it. And next time I request Kamran Abbasi Saab to at least give minimum 1 hour to 1 hour, 30 minutes to a presenter, so that they can furnish their knowledge or share their knowledge with the people, because we rarely get these opportunities where we can deliver our knowledge, or we can share, or we can interact with the audience. It will be more appropriate in future if you get the time assessment by the speaker instead of allocating 45 minutes to everyone. Anyway,
then you can continue it, because Yunus Barki is facing a problem in the connectivity, so I am basically coordinating with him on WhatsApp.
okay.
So you can continue. You can continue.
Okay, thank you, Kamran, thank you. Then we have the sand filters, multimedia filter, cartridge filter, and ultra or microfiltration membranes, which we can use. This is a typical pre-treatment scheme in which all the required equipment has been installed, but that depends. That depends on your feed water quality. Either you require only sand filter, or you require activated carbon as well, or you require the softening, or you require the chlorination. Unless the complete analysis is available for the source of water, an appropriate treatment cannot be proposed by any system manufacturer or supplier. Now, I'm just sharing a data sheet with you that pre-treatment, how, at what time, what is the requirement on how to handle any contamination by these through pre-treatment. Suppose on the pre-treatment option, acid addition. By the acid addition, you see on the, if calcium carbonate is excessive concentration, you can use the acid addiction scale inhibitors. You can just see these all options available for the pre-treatments, and every option is not effective for all contaminations. You have to select from these options that which pre-treatment you have to select for the smooth operation of the RO plant. It means that when you don't have all these parameters which are mentioned on the top of the table, these are not available, your designer cannot select an appropriate pre-treatment, and then later on you will be complaining through your supplier that you have not designed the system, or your RO plant is requiring the cleaning frequently, and such type of problem you may face. Desalination technologies we come up to. In desalination technologies, membrane technology, first we talk, and we have membranes of 4 categories available normally. And that is a microfiltration, ultrafiltration, nanofiltration, and RO membranes. And the particle size of all the membranes has been mentioned. Whatever the application we require, the suspended solid mostly. For the removal of suspended solid, we use the microfiltration or ultrafiltration membrane, which have a pore size of 0.1 to 1 micron. And ultrafiltration membrane has a they can remove particle size up to 0.1 micron. That ultrafiltration is normally used for if our source of water is potable, drinkable. For the disinfection, we can use the UF membranes. They can eliminate the microbes and biological contamination, and we don't need to treat the water through RO plants. Because the RO plant will remove the TDS, and you will have to do mixing of with the raw water or remineralization of the water. And this application depends upon your requirement. Here you can see what is the rejection, which membrane rejects what in membrane technology. Yeah, you see here in the microfiltration membrane, water, monovalent, multivalent, divalent, virus, they pass through the membranes. As their pore size is bigger, they only remove or not allowed to pass is the bacteria and the suspended solids. If you go for the ultrafiltration membranes, they will also remove the virus and bacteria and suspended salt. For RO membranes reject everything except the water, because the water molecule is one of the smallest molecule, the H2O, having a molecular weight of 18 molecular weight. Normally in our water treatment technology, we also relate it with the terms molecular weight cutoff size, MWCO. That depends upon the molecular weight. The cutoff size of the molecule depends upon the molecular weight of that. In the water, all molecules are bigger than the H2O. That is why the RO membrane has been specially designed. The second biggest molecule present in the water is sodium chloride, which has a 23 plus 35.5, 58.5 molecular weight cutoff size. And that is why all the membrane manufacturers, they test the membrane normally on the rejection of sodium chloride, because all other molecule combination present in the raw water, they are bigger than the sodium chloride. And the membrane data sheet will clear, they mention that, okay, our membrane rejects 99.5, 99.6, and or 99.7% sodium chloride. That is how they test the membranes for our application specially. This is the spectrum that will indicate you that which type of membrane we have to use, and that depends upon your requirement for the sugar, dye, insecticide, solubles, virus, dissolves, organics. You can see on the below row, you can see the molecular weight, and that depends upon which molecular weight you want to remove. For the bigger particles, you can see that we have the microfiltration membrane. For the ultrafiltration, you have the range up to 0.1 micron size particle you can remove. For the nanofiltration, 0.01 micron, and below is the molecular weight cutoff size. You can choose the membrane based on your application and the objective. Membranes are categorized basically in mainly three categories, because a lot of companies are doing the research work and developing the most efficient membranes for newer applications and to reduce the operating cost or the energy, for the energy conservation. And these are the tap water membrane, brackish water membrane, and brackish water low energy membranes, high flow membranes, seawater membrane. The choice of membrane depends upon the application as well. And to me, mostly in industry, the brackish water membranes are used for the saline water. Brackish or seawater are used. Low energy membranes give the lesser salt rejection as well. That depends what type of a water quality you want and what the membranes are to be selected. You need to be conscious about your system. Either you want to go for the low energy membrane, the high flow membranes, or the brackish water system. That is your comparison of the operating cost as well, and the requirement of your quality. Actually, these are the various membranes manufactured, like Filmtech, Hydronautic, Scotch, Float System, Torre, Disalgi, and this is the table which is relating the equivalency of the membranes with other manufacturer. Like for BW3400, you have Hydronautic CPA3 equivalent membrane, and Koch you have AA2 AA22 HR400. For Torre, you have, these are the equivalence table of various manufacturers. Most of the manufacturers, they have the replacement of the membranes as per if you have a CPA3, you can change it with BW3400, or if you have a BW3400 membrane, you can change it with CPA3. The performance will be almost same. These are some performance attributes for various type of membranes. I have picked it from the Dow. This is the data for the Dow, which is owned by DuPont now, and you can just have an idea from this presentation. I will upload this presentation on my YouTube channel as well. You can see that, and if you want the soft copy of the presentation, you can request Kamran Sahab, or you can request me by email or WhatsApp. I will send you the soft copy of the presentation as well for your review and understanding. This is again the performance attribute construction features of the membranes. How reverse osmosis works? Reverse osmosis is the process. We all know that the things move from high concentration to low concentration. This is the reverse of that. I mean, we are having a clean water on one side, H2O, and all contamination is being rejected by the stream. It means it's a reverse, and this is the principle which through which the osmosis and reverse osmosis works. I will skip that because I was running short of the time. And this is how the reverse osmosis work. The membrane allow only to pass the water through it, and the salt is rejected from the reject stream. This is a continue. We have a couple of options sometime to work on. And I have observed that in industry, sometimes they require the ultra pure water, and it is a minimum requirement, not a continuous requirement. You can have a continuous process. You have a batch process, mean you can collect your product of RO product or permeate in a one tank and recirculate in the same RO to get the better quality as well. And the continuous and batch process, sometimes to increase the recovery, the reject is again fed into the stream, for especially when we go for the high recovery system. Recycling of reject is sometimes become the essential requirement of the system. Single stage system means that we have either one, two, or three module all being fed directly from the feed pump. This is single stage system. This is two-stage system. All in first stage, we have all modules are being fed. The water and the reject of the first stage is being fed to the in the second stage. Similarly, and the product water from the first stage and the second stage, it is collected and it is combined for their storage. And this is a three-stage system. That's the same principle. The reject of first stage, second stage, in the moves to the subsequent stages. Physical arrangement of vessels. You can stage one. This is called the array configuration. This picture represents the array configuration of 4:2. It means in a first stage we have 4 pressure vessels, and in second stage we have 2 pressure vessels. It is the first stage that is known as the array in our term of the design. When you will observe the membrane projection, and you will see array configuration there. 4:2 is not, and if we go on different, we can see this is the single array for configuration. You will see the second 2 array configuration, 3 array configuration, 3 into 2:1. This is the below picture is related to 3 arrays configuration of the system, irrespective of the how much pressure vessel installed in a first, second, or third stage. But the important is this is the concept of array configuration, which I wanted to share with you, and that the path length is of normally. I have already explained. It also depends upon the array configuration and the recovery on that as well. Water treatment is a technology. It's not engineering. Each slide requires a couple of hours to make you understand this thing. And inshallah, I will keep on putting my struggle to dissipate my knowledge with the professionals who are interested or intend to work in the water treatment or working in the industry or ambitious to grow or make a career job, a water treatment field. I'm available to support them all the way. And it's my mission that what the knowledge I have gained in last 30 years, If Allah give me the life, I will definitely share it with on my YouTube channel, through webinar or the CPD courses through PEC, or inshallah, I will contribute for my national development. These are recovery factors, various concentration factors, typical recoveries, seawater RO, maximum 50%, concentration factor 2 means your reject will be twice concentrated. Brackish water RO 70%, 75% recovery. The concentration factor mean, I just would like to explain the one that if we have the 75% recovery and feed TDS are 1000, the reject TDS will be 4000. And if we have the brackish water and 80% recovery, the reject water have 1000, then the feed water have the 1000 TDS, reject will have a 5000. If we at 90% recovery, the concentration factor on the reject side of the water will be 10. That's just an idea for you how to estimate based on your reject. If you know the feed water, you can determine that your reject water concentration will be rich with the TDS at various recoveries. If the sea water, we have a 50% recovery, 30,000 feet water TDS, the reject water will be having a 60,000 TDS as a factor of 2. And for you can see the number of stages. For seawater, normally we have one stage, and brackish water we have two, three, and up to 80%. If you want to go for the 90% recovery, we have to go for the 3 stages. These are the RO permeate flux, which they are recommended that the RO permeate. I think this slide is coming again. I have already explained. And these are some conditions which I have explained at the 50% recovery. If you have a TDS 1000 in the feed, you will be having reject around 2000. And the product, you will be having this. I have made the feed constant 100 cubic meter per hour and TDS constant. And you can see the impact of pressure and the recovery with the constant feed water condition like flow and TDS. At 50%, we'll be having the reject water TDS around 2000 and 75% recovery at will be having around 4000, and that's around 685%. That's what I indicated in the last slide, and this has been transmitted in this slide to for you better understanding with the recovery, reject, and product variables. Now, this is another slide, recovery. Now, in the last slide, we put the feed constant, and in this slide, we have put the constant product. If we keep the product constant, 50 cubic meter per hour, you can see from the each stream. If product at the 50% recovery, you need the feed 100 cubic meter. And at the 75, you will be needing 66.7. And at the 85%, you will be requiring 58.8. It means that when you increase the recovery, your feed water consumption will reduce. And so as your pre-treatment cost, capital cost will also reduce. Other variables which are the main factor which affect the performance of RO plant are pressure, temperature, recovery, feed water, salt concentration. These are the factors. If the concentration of the source changes, the characteristic of water, obviously it will disturb your process parameters. And I am just running. These are the symptoms and causes of various foulings. And that is shown that if your permeate flow is increasing, and then the salt passage will increase, and differential pressure, you can see no change. At the bottom, you can see not changing, direct causing oxidizing, free chlorine, ozone. These are the parameters which I have summarized in this table that you, from this symptom, you can see the causes and the corrective action. whatever the symptom is, accordingly, you can you can have preliminary diagnostic of your system, the what type of a falling and what is the cause and what is the corrective measures. This will indicate you all those situations which normally we will face during the RO system. This is the pressure impact. As the pressure increases, the salt passage permeate get the better. With the temperature, if the temperature increases, all other parameters get constant, the permeate flux, salt passage will increase because the surface tension of the water will decrease and the salt passage will start increasing when the temperature is increased. It's vice versa as well. Similarly, this is the case of the recovery. I have explained in my previous slides about the recoveries that all depends upon your feed water characteristic and the path length and the number of stages. This is the summary and graphics presentation of those parameters which I have already explained you regarding the flux of the system, salt rejection, feed concentration, and rejection and performance monitoring parameter. It is very important for you that you must maintain the log of these parameters: feed water temperature, feed pH, feed and permeate conductivity, feed SDI and ORP, feed permeate and concentrate. These are the critical parameters. You must ask your operation team or that they must maintain the log register of these parameters. You can easily diagnose that in which, at what time, what went wrong. Because if the pressure will increase, it will gradually increase and damage the membrane. If the antiscalant dosage is stopped or the antiscalant dosing is stopped, the level of measurement that will indicate that what the root cause of that problem. The recording of data is much mandatory requirement and for the system, and so that you can fix the problem when it started and how it increased. I got the final warning from my host that take Q&A. Okay, let me finish it in a minute. Membrane cleaning. You can review the whenever our normalized permeate flow dropped by 10% or salt passage increases, that indicates the requirement of cleaning. What are the following? For foulings to the membranes: inorganic salt, calcium carbonate, metal oxide, silica, biofilm, organic. These are the contaminants. You can see this picture. It will show you how the membrane feed spacer with biofilm look like when the biofouling occurs. And these are the scale membranes. This is a membrane with permeate back pressure. This is the high pressure drop due to the biofouling. I think, my friends, I have these contacts given on the screen. You may contact me by email or by WhatsApp. I will send you the presentation, or you may join review this presentation after a couple of days on my YouTube channel. And now I'm ready for the question answer session. Any question, please?
So yeah, the question is if the alkaline increases, it means the pH shift from acidic to alkaline, but in your side, the pH shift from alkaline to acid with respect to temperature increases. Can you explain how?
If the alkalinity increases, it means the pH shifts from acid to alkaline. But yes, alkaline pH normally causes the fouling. That is due to the scale formation. Then it increases the scale formation. And we have to avoid, we have to design the system where the scaling of the membrane can be avoided. And whenever the water chemistry changes, we have to change the pretreatment options. We have, in such cases, we might be requiring the acid addition in the pretreatment.
The second question is how to remove microbial fouling from RO membrane?
This cannot be basically microbiological fouling. These are but with the alkaline solutions, we remove these biofouling, or we do the cleaning of the membranes with the alkaline solution for the removal of these microbes or the biological fouling normally.